Hi everyone, welcome to my channel. Today in this video we will discuss a new topic about scalars and vectors. Okay, so in our physical world we will have to measure large number of physical quantities, and the physical quantities are associated with the magnitude and proper unit of measurement. In our previous videos we have already discussed about units and measurement. Okay, so physical quantity can be expressed as the combination of magnitude and unit of measurement. Here m is the magnitude and u is the unit of measurement. Okay, for example, if you have the measured value of a piece of wire as 2 meter, then 2 is the magnitude and meter is the unit of measurement for length. Similarly, you can have measurement like 4 kg, then 10 degree Kelvin, like this. Okay, you will just have a large number of physical quantities to be measured. Okay, so now all these physical quantities can be classified in two classes. One is scalar quantity and another is vector quantity. Okay, so scalar quantities are always associated with the magnitude. Okay, this is associated with the magnitude along with the proper unit of measurement, and the vector quantities are associated with magnitude along with the direction also. That means to define a vector quantity you have to know the direction along with the magnitude. Okay, so this is the basic difference between scalar and vector quantities. That is, scalar quantities can be defined by only the magnitude, but to define the vector quantity you have to know about the information of magnitude and as well as the direction. Okay, so some example of scalar quantities are speed, then mass, then temperature, then area, volume, density, etc. Okay, so you will get large number of such type of quantities that can be classified as scalar quantity. Similarly, vector quantities are velocity, displacement, acceleration, force, momentum, weight, etc. Similarly, here also you will get large number of physical quantities that can be classified as vector quantities. Okay, now let's see how scalar quantities and vector quantities are differ from each other. Okay, suppose this is a car and you have an arbitrary information that the car is moving with a speed 30 meter per second. Okay, you just have the arbitrary information about the movement of the car, that is, it is moving with the speed 30 meter per second, but you don't know in which direction the car is moving. Okay, so therefore the term the physical quantity speed is a scalar quantity, as it is described only by the magnitude 30 meter per second, but not have any information about the direction of motion of the car. Okay, now what will be about the vector quantity? Velocity. Okay, this is the car and you have the information that the car is moving with velocity 30 meter per second. The car is moving with velocity 30 meter per second along this direction. Okay, from this point to this point. Okay, so you have the information that the car is moving with velocity 30 meter per second along this direction. Okay, the car is moving along this direction. So you have got the magnitude of the velocity 30 meter per second along with the direction also. That means you know in which direction the car is moving. Therefore, the term velocity is associated with the magnitude as well as the direction of movement. Therefore, the velocity is termed as vector quantity. Okay. Now, another quantity, distance. So, what is distance? Distance is another physical quantity in case of a moving body. And what is distance? The path length covered by a moving body during its motion. This path length is called distance. Okay. So suppose the car is moving from this point to this point. That means what? During the motion of the car, the car is covered this length AB. Okay, so suppose you have an arbitrary information that a car is moving and during the movement of the car it has covered a length AB, but don't know about the direction in which the car is moving. So this path length, without any information about the direction of movement, this path length is termed as distance. Okay, so distance is the total path length covered by the moving body during its journey. Okay, so it is not associated with the information about the direction. Therefore, the speed is a therefore the distance is a scalar quantity. Now, suppose you have an information that a car is moving from point A to point B in this direction. You have an information that the car is moving from point A to B in a particular direction, in this direction. Okay, so then this path length AB covered by this moving body will be termed as displacement. Okay, this path length is termed as displacement. So what is the difference between distance and displacement? So distance is the path length covered by the moving body during the entire journey, but displacement is the path length of the moving body between the starting point and the ending point during the journey. Okay, displacement does not give you the information about how the moving body is traveling, through which path the body is traveling during its entire journey, but it is only associated with the starting point and the ending point. Okay, so this is the displacement, and it gives the direction between the between the starting point to the ending point. So displacement is associated with the magnitude along with the direction of movement. So that's why displacement is a vector quantity. But distance is the total path length covered by the moving body during the entire journey from the starting point to the ending point. Okay, distance is related with the path covered by the moving body, how it is started from the starting point and how it arrive, through what way it will arrive on the ending point, the distance will associated with that type of motion of the moving body. So distance is related with the magnitude but not the direction. So it is a scalar quantity, but displacement is associated with the magnitude along with the direction also. So therefore displacement is a vector quantity. Another example is that suppose this is a block having a mass m kg. So you know what is mass? Mass is the substance of the body, amount of substance of a body, and it has only the magnitude along with the proper unit of measurement of mass. So it is a scalar quantity. But if you are going to measure the weight of the same body having same mass, then what will happen? You know what is weight? Weight is the force exerted by the acceleration due to gravity. That means because of the force due to gravity, the body has the tendency to move towards the center of the earth, and this force will give you the measure of the weight of the body. Okay, so that means what? This is the weight. That means the body of mass m kg is has the tendency to move towards the center of the earth, and it depends on the amount of mass of the body. So it has a direction towards the center of the earth. So therefore this weight is associated with the magnitude along with the direction towards the earth. Therefore this mass is only a magnitude. Therefore this is a scalar quantity. Mass is a scalar quantity, but this weight is associated with the magnitude of measurement along with the direction. Therefore weight is a vector quantity. Okay, so these are some examples of different physical quantities which clarify the difference between scalar and vector quantity. Okay, now let's see the correct difference between the scalar quantities and vector quantities. Okay, here we just try to list about the differences, basic differences between the scalar quantity and vector quantity. So first difference is scalar quantity have only magnitude, that this point have already discussed, and vector quantities have both the magnitude and direction. Okay, second point is scalar quantities are one dimensional. It has only the magnitude, no direction is associated with the scalar quantity. Therefore this is one dimensional quantity. Okay, so but vector quantity can be resolved into it can be one dimensional, two dimensional, or three dimensional. Okay, that means what? Vector quantity, suppose velocity, a body car is moving in a straight line. Okay, if a car is moving in a straight line with a particular velocity, then the velocity is one dimensional. Okay, if a body is moving in a straight line with velocity, with a particular velocity v, then it is one dimensional. Now if a car is moving, or if an object is moving in this direction, then it can be resolved into x direction and y direction. I think all of you know about the Cartesian coordinate x, y and z. Okay, so if a body is moving in xy plane, then the velocity of this body can be resolved into x direction and into y direction. Okay, v1 and v2. This velocity can be resolved into two directions. So for the body moving in a plane can be resolved into two directions. Again, vector can be dimensional. That is, one example of three-dimensional vector is unit vector. Okay, unit vector is that vector which has the value 1, and these unit vectors are only used to specify the direction of a vector only. Okay, it is only used to specify the direction. Okay, so that means what? Vector quantities can be one-dimensional, two-dimensional or three-dimensional. Another difference is scalar quantity can be sensed by sensing magnitude only. So scalar quantity is what? Suppose speed is, in our earlier example, speed was 30 meter per second. So this is the magnitude. If you want to sense the speed of the moving body, then you have to just sense the magnitude. Suppose this is 40. If you will sense the magnitude of this moving body, then the speed of the body will be sensed. Okay, so to sense the speed of a moving body, you have to just sense its magnitude. But in case of vector quantity, vector quantity, it can be sensed by three ways. That means, suppose velocity v is equal to 30 meter per second and it is moving in this direction. Then if you want to sense the velocity of the moving body, you can sense the magnitude. That means, suppose this is 40 meter per second but moving in the same direction. Okay, so keeping the motion of the body in the same direction, you can sense the velocity by sensing only its magnitude. Okay, so this is one way. Another way is you can sense the velocity by sensing its direction, meter per second. It is moving in this direction. Now keep the magnitude of the velocity same, you just sense the direction of the moving body. Then also you can sense the velocity of the moving body. And another way to sense the velocity of a moving body, suppose you have the v equal to 30 meter per second and the body is moving in this direction, then you can sense the velocity by sensing its magnitude. Suppose this is 40, now it is 40 meter per second and direction is in this direction. In this case, you have sensed both the magnitude and the direction of the motion. So in this way also you can sense the velocity. That means what? Vector quantities can be sensed by sensing its magnitude, direction, or both the magnitude and direction. Another is if you operate on two or more scalar quantities, then the result will be again a scalar quantity. Suppose 30 meter per second plus 20 meter per second give you 50 meter per second. That means if a body moving with 30 meter per second and another body is moving 20 meter per second, okay, then what will be its then the new speed will be 30 meter per second plus 20 meter per second. It will give 50 meter per second. Okay, so this 50 meter per second is again another scalar quantity. But in case of vector quantities, operation over two or more vector quantities gives you another vector quantities, or sometimes it also give a scalar quantity also. Okay, and another is difference is scalar quantities cannot be resolved. It is one dimensional, but vector quantities can be resolved into 2 dimension or into 3 dimension. Okay, so these are the differences between scalar quantities and vector quantities. Now let's discuss about the characteristics of vectors. So first is notation of the vector, how we express a vector quantity. Okay, what is the notation? So a vector quantity is expressed as the bold face of a letter or by an arrow over a letter, that is a or a over arrow. And next one is magnitude of vector. Two vectors a and b can be said to can be magnitude as, this is modulus of a is equal to a. This is the magnitude of vector. And next, equality of vectors. Two vectors a and b can be said as equal if and only if its magnitude and the direction are same. Okay, that is a, b. These two vectors have same magnitude and again it has same direction. Therefore these a and b vectors can be said as equal vectors. Next, multiplication of vectors. If a vector is a is multiplying by a number lambda, then the new vector will be changed by a vector lambda keeping its direction same as before. That means what? If a vector a is multiplied by a lambda, okay, then this new vector lambda a will be changed by the amount lambda, but its direction will be same. If the initial direction of a was in this direction, then after multiplication by this lambda, the magnitude of the vector will be changed by the factor lambda, but its direction will be same. Okay. Next, another is, suppose this is a vector a. So suppose this vector a is multiplied by factor 2. Here lambda is equal to 2. Okay, that means what? Suppose this is a vector a and we have lambda is equal to 2. That means a is multiplied by 2, then its magnitude will be twice of a. This is twice a, but the direction is same. So this is the result of multiplication of a vector by a scalar quantity. Okay, so then the new one will be twice a. Another is null vector. The vector whose magnitude is the vector whose magnitude is 0. This vector is called null vector and it is denoted by this O, and it is written like this. A minus a, this is O is here, and the result is 0. Okay. Null vector, this is, and the result is 0. The magnitude of the vector whose magnitude is 0, this is called null vector. Okay. So, and again null vector can be obtained as like this. This is equal to 0. Okay. So next one is unit vector. A unit vector is one whose magnitude is 1. It has no dimension and unit, and it is used only to specify a direction only. It is denoted by a letter and a cap over the letter. Okay. So thank you for watching. In our next video we will discuss about how vector quantities can be resolved, and we will discuss about some other important points relating to the vector quantities. Okay, thank you.